Alright, welcome. In this video I want to show you how to draw to the canvas element in HTML web page, an HTML5 web page. And that's going to be the primary way that we're going to paint and draw things for our game. So the first thing we're going to need to do if we want to paint to a canvas is create a canvas. That means somewhere in our web page we're going to have to include an HTML5 canvas tag, and that operates very similar to other HTML tags like an image tag or a div tag. And the most important thing, at least for us right now, other than some of its style parameters, which I've left out, is just giving it a name. And that is giving it a name that we can pick out. Now, I said I've left out some style parameters here. By style, I mean things like the size, what's its width, its height, maybe what's its background color, does it have a border, things like that. You can include those in a style sheet, or you can include them right in the canvas tag here. I've just left them out at the moment since they're not as important as to what we want to do, which is we want to be able to access the canvas tag. To be able to paint to it, we need to be able to access it from our code, our JavaScript. So to do that, there's sort of a two-step process. The first step is we're going to grab this canvas tag itself. And since we've given it a name, its ID in this case is Game World, we can fetch that canvas tag by looking for the tag that has the ID Game World. And we do that by using this method called getElementById. Now this method is built in to all modern web browsers, built into the document, and the document is a reference to the tree of HTML tags that is the web page that you are currently viewing. Now that tree could be very in-depth with lots of nested tags, but in the example that I'm using, it's very, very simple. Inside the web page body, there's really only one tag, which is the canvas tag. Occasionally I add a few more for instructions to my users, but this is the only tag that I usually include, but still using this method is how I'm going to fetch it. It sort of searches quickly for you through those tags and finds the one you're looking for. Once you have it, well, we don't draw it directly to the canvas. In fact, we have to draw to its context, what's called its context. And the canvas's context is fetched by calling the getContext method. So this is sort of the setup for our canvas. If we want to use it to draw to it, to set it up, we need to basically do these three steps. Once we have that, this CTX object is what we're going to be able to use to do all the drawing that we want to do onto that canvas. Now, I didn't say too much about the context, and I won't say too much other than that there is a 2D context and a 3D context, and at least for the videos that I'm going to be presenting here, we're going to stick in the 2D context. So sprite animation is a 2D concept, and if you want to do 3D animation, you can do that as well using the 3D context. So now that we have the canvas set up, what can we do to it? Well, we can draw different shapes. We can maybe write text to it, although there's usually better ways to write text in HTML than on a canvas, so we can do that as well. And we can, maybe the most important bit is we can draw images on the canvas. And I'm going to spend a little bit of time here just exploring some of the tools we can use on the canvas, but in the end, probably the majority of what we're going to be doing is just drawing images on the canvas anyway. So let's start with that now, or let's start with some shapes. And when we draw text or shapes, there's going to be two concepts that are relevant to us. The idea of stroking or filling. To stroke is just to outline the shape or the text with a single stroke, and then to fill is to fill it in, and then we can do both, which would allow us to present maybe a different stroke color and fill color, giving us a different outline from the fill. Maybe the final last thing that's of relevance and importance when drawing to the canvas is that the origin of the canvas is in the top left corner, and this is just following a convention in web programming, which is that our origin is in the top left, and that's because the web page itself sort of grows down, and since it grows down, we want sort of as it grows to get larger and larger, so that means the positive growth is downwards. Now, drawing to the canvas requires us to set certain things, like maybe we want to know what color we want to draw, how thick a line we want to draw, various things like that. Maybe we're writing text, we want to know what the font is. All of these different parameters we call style parameters, and that is the style of the drawing, and it's similar to the style that we might use in other HTML elements. And when we want to set the style parameters of the canvas are actually global parameters, which means if we change the color to red, everything we draw now is going to be red. And if we change the opacity, how transparent what we're drawing is to say 50%, now everything that we draw will be 50% transparent. And as a result, you get into this habit of sort of changing the style, doing something, and then changing it again, doing something else. So maybe you want to draw a rainbow, you change your color to red, then you change it to orange, and so on. You go through the different colors until you're done. And sometimes this can be a little bit problematic in that you can, set a whole bunch of settings and then forget what your old settings were. You want to go back to the default. And luckily the canvas builds in sort of a save and restore method that will just save all the current global variables, and the next time you call restore, it will just restore them to that. So if you do a bunch of finicky changes and don't know how to undo them, you can just do a save and a restore. Now, our purpose for thinking about this is more just to keep this in mind, that when we make changes, we either want to immediately undo them, or just be conscious that next time you get around to doing a drawing, just because you set the color of your paint to red earlier doesn't mean someone hasn't changed it to some other color, some other method hasn't changed it by the time you get to now. So it's probably a good idea to change it back to red if that's the color that you want. And so for that reason, we've got these global parameters. Now, I'm going to use two of them right now. Here, fill style and stroke style. There's a couple different things we can set with our style parameters, but these two will set the color of the particular brush. Here I've just set it to white because the default background is black that I'm working with, at least today. We can draw certain shapes. Now, most shapes are going to either be a rectangle, a circle, a combination of parts of rectangles or parts of circles, or then we're going to get into some more generic sort of polygon-like shapes, in which case we're going to rely on just line segments and draw lines. So at first I'm going to just say, how can we draw a rectangle? Now, rectangles default to axis aligned, and I'll talk more about that, especially when we get to collision, but that means not rotated. Our rectangles sort of sit flat on the x-axis. And so to state a rectangle, we only need 4 parameters. Technically, we just need to know the top, bottom, left, and right, but usually the way that we state that, at least programmatically, our convention, is an xy coordinate of the top left corner, and then a width and a height. And so that's how we use that in the draw rect as well. We have a top left corner and a width and a height. So this will draw a rectangle that starts at pixel or point 100, 110, and then draws a 100 by 100 square, I guess, in this case. And this will fill it in, although if we called stroke rect instead of fill rect, it would only draw the outline for us. A circle is drawn using the arc method, which technically is used to draw arcs. And an arc, of course, is sort of a circle segment. And so the arc method can be used to draw a full arc, which is a full circle, and that's what I have suggested here. In this particular case, we're going to be using the built-in path drawing tools in the canvas, where we're going to at least start out our path by saying, let's begin a path. And from that path, we can draw line segments or arc segments. In this case, we're just going to draw a single arc. In this case, we state a couple different parameters. We state the center point, so where is the center of our circle at 50, 50? What is the radius of our circle? In this case, it will be a radius 25. And then the next two parameters tell us which part of the arc we want to draw. So this actually says start at 0 radians and draw 2 pi radians, while a circle is 2 pi. And so that will draw the full circle for us. 0, if I believe, I can't remember this 100%, I think it's out to the right, straight out to the right. In which case, if we did this with 0, 1 pi, 1 times math times pi, we would get a hemicircle, a single half circle. And I believe the rotation is below. Try it out for yourself. In fact, I'm going to try it out in a second so I can verify this myself, which way our arc is going to go. Here I've called fill and stroke, which means this will fill that arc and this will stroke it. Now, the arc, when we draw it, if we draw a partial arc, like the half circle that I said, it will only fill in that half circle, connecting the two unconnected points in that half circle and filling in everything else. Maybe we'll experiment with that a little bit as we look at it as well. Finally, we can draw line segments using the begin path function as well. The begin path will start a new path, and then we can call one of two methods. Either move to, which is moving our pen, like imagine that's picking it up off the paper, moving it to location, and then putting it back down again, potentially at least. The line to does the same thing, moves the cursor or moves the point to the new point, but it draws a line along the way. So we can draw any shape we want here if we know all the points of the shape by just starting at one point and going line to, line to, line to, line to, line to, and then using move to when we want to pick up our pen and start a new one. Now here again, I've called stroke. That will only draw the lines, but if we called fill, it would try and fill them in as well. Try and make that into a closed form and then fill in that form. The last method that I want to look at actually has three different prototypes here, and that's the draw image function or method. And again, here I have it called from the context. It's going to take as its first argument an image, and we're going to use an HTML image similar to the kind we were loading with the asset manager a couple videos earlier. Now, the prototypes for this draw image also take some destination coordinates, x, y, and width, height, because the image that we're going to draw here is also a rectangle. So these first two prototypes, if we just tell it the XY, it will draw it the shape, or rather the size of the image that we actually give you. If we instead tell you the destination width and height, it will shrink or skew or make that image, sort of wider, skinnier, taller, or shorter, depending on this width and height. And so we can use that to scale our image to maybe we want to make it half the size or twice as big, something like that. But the prototype that we're going to actually use is the more sophisticated one, which allows us to draw only a portion of the image that we have. So instead of drawing the whole image, we'll only draw a portion of that image. And the reason we're going to make use of this is because, remember, we're going to be using a sprite sheet for our animations. And the sprite sheet's going to contain all of the frames of an animation, but at any one time, we only want to draw one frame. So we're going to pick out which frame we want and then tell you where we're going to draw it. The last thing that's a little bit peculiar about the canvas are doing our standard transformations. Say we want to paint an image, but we want to flip it, or we want to paint an image, but we want to rotate it a little bit. And then translation is our more standard one. We can do that somewhat straightforwardly, but reflections and rotations are not as straightforward. In Canvas, again, because everything is sort of treated global, our style parameters are treated globally, that when we translate or float or rotate something, we're actually not rotating the image we're drawing, we're rotating the whole canvas. And then we're drawing something. And of course, if we rotate the canvas that we're painting on and we draw something on it, that is in a sense like we've rotated the thing that we're drawing. But to do that, we need to somehow rotate back the canvas afterwards to get it back to the way we expect to be looking at it, the right frame of reference. And so to do this again is a little bit complicated, and I think I'm going to experiment a little bit that in a series of videos just to show how translation, reflection, and rotation works in the canvas. But here let's just take a little bit closer look at it. First of all, translation is going to allow us to move the origin of the canvas. Now, I mentioned one reason we might want to do this is move it into the bottom corner if we're more comfortable with that. Okay. Still, that's not going to allow us to draw in the way we expect. Plus, will still be down. The region that we will now have will be the negative portion. But if you're sensitive to that, you can still do that. Another reason to do this, well, in some games it might be useful to have the origin of your game world to be in the middle, not in the top. And Seth Ladd, who I copied this from originally, that was the case in his game. He had sort of the center was this planet Earth, and you're defending it from aliens, and so it made sense to translate it to the middle. Now, For most of the time, if there's not a good reason to translate it, you're probably just going to leave it to save yourself a little bit of extra calculations and pain. And so in almost every one of my games, my origin is still in the top left. So translation I haven't touched as much. Reflection and rotation are things that can be done. Now, reflection is sort of the mirror image. We can reflect, vertically, horizontally, or diagonally. There's other ways we can reflect as well over any particular line if we like. And reflection is something that was definitely used a lot more in older game programming as a way to save memory. So instead of having the image saved both in a left-facing and right-facing direction, the image could be saved only in a right-facing direction, and then some simple math could translate it by flipping it, drawing it to the left instead of drawing it to the right. Now we could do the same thing here, but for a couple reasons, this is not how I'm actually going to do Mario. The reason is, first of all, doing the actual reflection can be a little bit costly in terms of energy. Memory is now pretty cheap, whereas the computational power to do the reflection might be a little bit more costly. So we might not want to do that. And then also just keeping the extra memory and having an extra image to the left is actually quite simple. And so there's not a lot of extra mental operations that we need to carry out to do it. We just have to do a cut and paste, duplicate the code for the right-facing images, and now we have left-facing ones as well. Now, why did I say that it's going to be a little bit more expensive doing the reflections in the canvas is because, once again, when we do the reflection, we're not just reflecting what we're trying to paint, we're actually reflecting the whole canvas. We're going to flip the whole canvas mirror, then we're going to paint the thing, and then usually flip the canvas back, and that will again give us the impression that what we have flipped is the thing we've drawn. The thing we've drawn, again, is still just drawn normally, drawn on a flipped canvas. The last thing that we can do is a rotation, and likewise, again, maybe the same lesson or rule of thumb that I'm pointing out here is that when we do rotation on the canvas, we're going to get rotating the whole canvas. Rotate the whole canvas, then paint the thing and rotate it back. So doing the calculations to figure out where should I paint it, how much should I rotate it, and so on is not straightforward or as trivial as knowing how much you want to rotate the image you want to paint by. So again, I'll have a video to give a little bit of an explanation of how to carry out rotations the way that you would expect them to be carried out. So for the remainder of this video, I just want to experiment a little bit with what we've just looked at, which here we have our this simple code I just showed on the slide. I've pasted into my Mario's draw method here. So I've sort of commented out everything else from my simple Mario, where instead I've actually changed it to white and red so that we have a white and a red to differentiate between filling and stroking. And I've made a few changes here actually, and we can see the output on the left hand side. So we can see a red stroked rectangle here that's a 100 by 100. We can see a red line that I drew from 100 100 to 200 100. And then we can also see this arc that is both filled and stroked. You can just see the red outline as well. For instance, we could comment out this one here, and we see the fill is left with just, or the fill is no longer there, so we are left with just the red stroked outline of the circle. Let's do an experiment. Let's change this to half a circle and see which half a circle we get. My guess is the bottom half. Am I going to be right? All right, so I guess I remembered from before, and maybe we could change that to a quarter circle, and we might get something like this. And actually now I'm going to uncomment the fill, and we see that if what we were hoping to get was a little sort of pie piece, what we see is that's not exactly what we do get. And I remember when I was using this and I wanted little pie pieces, I used it. I just wrote a little function that drew the triangle bit on that I wanted as well. Okay, so you want to add to this a little triangle that joins you to the center bit. And that's because this is just how the stroking and arcing happens to work. Notice that if I turn this back to a half, we get, that one sort of works out right just sort of by lucky, but a 3/4 one, yeah, gives you this shape again. So you might want to write again, a little method that will draw pie pieces if that's what you're trying to use the arcing for. But more often than not, we use the partial arcs with no fill at all, and then that gives us what we want. Okay. Now, you'll notice I've only drawn one line here in my line 2, but in our path we can combine arcs and line 2s, so we can draw, you know, maybe a shape that is round on one end but then has sort of straight edges. All of these things we can draw, and of course programmatically you could draw a little method that draws, I don't know, an image, a face, whatever it is, but that can be a little bit painstaking, encoding every single line that you're going to draw. So instead of doing that, we're usually going to default to drawing images. And so I think I'm going to end the video now. We'll talk about drawing images in that next video. So thanks a lot for watching, and we'll see you in the next video.